Okay, the Hangout on Air is live. Welcome everyone to the Virtual Jug. Our session is going to be all about Jenkins X, and we have none other than James Strachan on the line. How are you doing, James?
Very well, thank you.
Awesome.
It's great to be here.
It's our absolute pleasure to have you, James. And
Thank you.
among other things, James, you're obviously known as the lead of Jenkins X projects these days, but you're also well known for being the creator of Groovy and also Apache Camel.
Yes.
Is that
Yes.
would you say that's for your sins or your?
They've all been fun. I've enjoyed all of them. Yes.
Actually,
But Jenkins X is the coolest.
I'm
Now.
a very big Groovy fan, actually. So
Oh, excellent.
I do like Groovy, and I'm very interested in Jenkins X as well. And where are you today, James?
I'm in Neuchâtel, Switzerland. I've been with meetings with CloudBees folks all day. So yes, it's hot and sunny here. I'm by the water. It's
wonderful.
nice.
You're normally London-based, right?
I used to live in London. Now I live in the country. I'm kind of Froome way near Bath.
Oh, okay. Oh, near Bath. Very nice, very nice.
Very nice.
Awesome. So before we get started with this live session, I'd just like to say for people who are watching on the live broadcast, if you are interested in asking questions, please do go to the Virtual Jug Slack group, and you can ask questions in the live channel. Live session channel. Also, click on the little cog to make sure you're running at the highest resolution, to highest video quality, as there's going to be a whole bunch of demos on this as well. Okay, so yeah, questions via Slack, and I'll pass them straight over to James. So please do get started, James, and we'll talk about Jenkins X.
Let me go for it. Awesome. Yeah, let me share my screen and hope this works again. Okay, there we go. Is my screen coming up okay?
It's perfect, yep.
Excellent. Okay, let's get started. So before I get into what Jenkins X is, I just want to step back and talk a little bit about the IT, the software business, and what's happened in the last 5 years. So I've been worked in software for a few decades now, and it feels like the last 5 years, more things have happened than quite a few decades combined in what it means to build software, deploy it, deliver it, manage it, orchestrate it. So a whole bunch of things have happened in the last 5 years. So there's now a huge move from on-premise to public cloud. This has been happening for quite a while, but it's particularly accelerated in the last few years in particular. Then coupled with this, there's a move away from virtual machines toward containers. Why? Mainly to reduce cost, right? Containers are smaller, take up less memory and CPU and disk, because you're basically running less software. When you run a virtual machine, you're running a whole computer with Linux and device drivers and thread schedulers and everything. A container is literally just a process, so it takes up less space. So moving to containers is a new big thing because it reduces your cloud bills. Then the next challenge has been, how do we manage all of these containers at scale, kind of like Google does? The last decade, Google has been using containers at scale to run everything. So when you do Google search or use any of the Google apps, all of that is running in containers at scale. So about kind of 4 years ago, Google open sourced a project called Kubernetes, which is basically Google's take on how to manage containers at scale. Since that 4 years, a lot has happened in the Kubernetes ecosystem. Red Hat joined the project, and then a bunch of other people joined, IBM, Amazon, Google, Microsoft. And 2018 is pretty much the year that Kubernetes won and became the way of managing containers at scale on any infrastructure, right? On-premise, any of the public clouds, any hybrid kind of cloud story. Right now, this year, 2018, Amazon has just announced EKS, like right now. The announcement is happening today, basically. So EKS is now a managed Kubernetes platform on Amazon. GKE on Google has been there for a while. AKS is going to be GA, I think, next week on Azure. Pivotal has adopted Kubernetes, Docker has adopted Kubernetes, Oracle and IBM's clouds have Kubernetes. So pretty much every cloud provider uses Kubernetes, which as a developer is now super exciting because now we have a single simple way of packaging and deploying applications, turning applications into Docker containers and using the Kubernetes metadata to deploy it on any cluster, right? I remember a bunch of years ago, people used to have heated debates in bars about should OpenStack adopt the Amazon REST APIs and all this kind of stuff because there was a worry of lock-in with the Amazon REST APIs. Well, now Kubernetes kind of hides the cloud provider in many ways. It's a simple abstraction for building distributed applications and running them on any cloud, which is amazing. So Kubernetes is totally amazing. even if you don't like Jenkins X, and I hope you do because it's awesome, but even if you don't, please look at Kubernetes. It's amazing technology. So another thing that's happened in the software industry is a move away from monoliths to microservices. We're all trying to be high-performing teams now. So there's lots of research, like the State of DevOps report, that has found how to become a high-performing team. So microservices is part of it, DevOps is part of it, hypothesis-driven development. The basic idea is we all want to do lots of small iterations of code and get that code in front of real users as quickly as possible. So then we can get feedback and we can do this iteration loops and go as quick as we can to deliver business value. To do microservices and to do this kind of stuff, we need continuous integration and continuous delivery to deliver business value faster. So if you're trying to be a high-performing team, now you have to figure out all this stuff now, right? So you need to figure out how to take your apps, whatever they may be. You need to set up your cloud of choice, whether it's on-premise or public or whatever. Set up Kubernetes. You need to set up environments like development, testing, staging. You need to move your applications so they're now containers. You need to figure out how to deploy those containers in Kubernetes and figure all that stuff out. Then you need to figure out how you're going to do continuous delivery. Continuous delivery is one of those things everybody wants. It's a bit like kind of teenagers and sex. Everybody talks about it, but not that many people actually really do it. But everybody wants to do continuous delivery. There's a new kind of term called GitOps that the Weave folks named, which is how should we manage environments like staging or production. And GitOps is a technique that where you just use Git source code to manage all of the configuration and versions and apps that you wish to deploy in each environment, so that if you make a change in production, you change it in Git, so that if anything goes wrong, you can just do a Git revert, right? So Git becomes the source of truth of all of your configuration. So rather than somebody tweaking something in production and other people in your team not knowing, keep everything in Git. It's easy to work as a team on complex things like infrastructure, right? Then on top of all of that, so we've got containers, we've got Kubernetes, we've got continuous delivery, we've got GitOps. Then we need to automate everything because you're going to be spinning up microservices all the time and doing continuous delivery on them. And then once you figure out all of this stuff, then you can actually do what you're really meant to be doing and deliver actual business value to your customers, right? So there's this issue we all need to face of how do we become high-performing teams using containers and continuous delivery in Kubernetes. And this is where Jenkins X comes in. So Jenkins X is a sub-project, a proposed sub-project of the Jenkins Foundation. The idea of Jenkins X is to give all developers their own naval seafaring butler that can help you sail the seas of continuous delivery, right? So the idea with Jenkins X is to try help you automate your continuous delivery and continuous integration on Kubernetes. So what does Jenkins X do for you? So the first thing Jenkins X does is install and configure a whole bunch of open source applications. By the way, Jenkins X is completely open source, just like Jenkins is. And Jenkins X packages up a whole bunch of different open source projects that are part of the Kubernetes ecosystem. The Kubernetes ecosystem is a stunningly diverse and rich and powerful community doing all kinds of different things. And there's an amazing array of tools that are being created in the Kubernetes ecosystem to help with development, testing, scaling, management, and operations, and all kinds of things. So Jenkins X picks a whole bunch of best of breed open source components to go with your Kubernetes to help you do continuous delivery. So tools like Helm from Microsoft, which is a package manager for Kubernetes, Scaffold from Google, which is a tool that helps you efficiently do Docker builds inside Kubernetes, but reusing various different techniques, like using Google Container Builder or something called Canico that does builds without using a Docker daemon. Then there's Nexus as an Artifactory repository. There's something called Monocular, which is kind of like an open source app store for Kubernetes. So there's all those kind of apps get automatically configured and installed by Jenkins X. So you literally just install Jenkins X and all that stuff just kind of works. You don't have to touch it. Then Jenkins X also automates the CI and the CD for your actual applications on Kubernetes. So it automates creating the Docker images for your apps, creating the Helm charts, which are the kind of the packages that are used for installing applications on Kubernetes. And it automates setting up the CI and the CD pipelines to do your releases and to handle pull requests, which I'll show you in a few moments. Also, Jenkins X automates promotions of releases through environments using this idea of GitOps. In other words, using Git repositories for staging and production, and managing promotions of new versions of applications through those environments using pull requests and CI/CD. In addition, it provides lots and lots of feedback. So how do we set up Kubernetes and Jenkins X? So the first thing you need to do is get Kubernetes and Jenkins X set up. Then you can get cracking and use Jenkins X to do all kinds of awesome things. So how do you do that? So the first thing you need is a new command line tool, a binary called JX for Jenkins X. So it's a simple statically linked binary. You can click on that URL and download it from the internet. You can use Brew if you're a Mac person. You can use curl if you're a Linux person. But basically install that tool, get that binary, put it on your path, and then you're ready to experience Jenkins X and use Jenkins X. Right, so let's talk about how we set up a Kubernetes cluster and install Jenkins X. So there's two approaches here. We prefer you to try the first approach. So the first approach is using a command called JX, create cluster. And then you give a parameter, which is the kind of cloud you wish to use. So do you want to use Amazon? Do you want to use Google GKE for Google Container Engine, or AKS for the Azure-based solution? There's a whole bunch of other alternate options. These are the big three for the big three public clouds. We do prefer you to try Jenkins X on the public cloud, just because that's kind of the best way of using Jenkins X. You can, if you really want, use something like Minikube or something, but then you're running on a laptop, and then you lose all the webhooks integration between, say, GitHub and your laptop. So we prefer you to try the public cloud if you can. You can use the free tier. All the big public clouds have a free tier. So you can use the free tier, try this out for a few days and tear it down, and it might cost you a cup of coffee or something. If where you work, there already is a Kubernetes cluster you're allowed to use and play with, the second option is JX install, which just installs Jenkins X onto a Kubernetes cluster. So if you can already talk to a Kubernetes cluster with like kubectl, JX install is the second option. There's much more help on that URL on that page. I'll share the slides after this talk, by the way. Here's a quick demo of how to do the install. I could do a live install, but I didn't want to because it's a little bit boring and because we're just sitting and waiting on infrastructure. But you basically type JX create cluster. In this case, it's GKE. And then it asks you a few things like how many nodes to use and which zone and whatnot. And it spins up a Kubernetes cluster, then sets up ingress so we can talk to the cluster, then installs Jenkins X. Then finally, the last thing it does is it creates 2 Git repositories for staging and production. By the way, a quick thing on Kubernetes. Kubernetes is amazing technology, but it's not the easiest thing to install and configure and manage. And friends don't let friends install and manage Kubernetes. Thinking of trying Kubernetes, I hugely recommend you try one of the managed services on one of the public clouds. So whether you want to go with Azure, Amazon, or Google, they all have a managed Kubernetes service, which basically means you click a few buttons on the web console or use this command line, and it will spin up a Kubernetes cluster for you, and it will manage it. They'll keep it running. They will do auto upgrades. They can do auto scaling and various other things. So please, I recommend don't try and install Kubernetes yourself. Life's too short. So we highly recommend managed services. Right, so that's installing Jenkins X. What does that give you when you've installed Jenkins X? So the first thing it gives you is a development environment where your development tools live. So things like every team gets their own Jenkins master. You might work at an organization that has like one massive Jenkins with a gazillion jobs inside, and it's really hard to see any of your stuff. With Jenkins X, each team gets their own master with just that team's builds in there. The Jenkins is already configured to use an elastic pool of build agents using Kubernetes pods. So there's no waiting for other teams' builds. If your Kubernetes cluster has capacity, your builds start instantly. In addition, you get various tools like Nexus and Monocular and so forth as well. But then also each team gets their own staging environment and production environment. In Kubernetes, there's a concept called namespaces, which lets you take a Kubernetes cluster and segment it into separate namespaces or kind of almost like virtual clusters. And what that means is if you deploy an application to staging, it only sees things in the staging namespace. So staging and production are completely isolated and they can't accidentally conflict, right? So if you deploy a test app to the staging environment, it doesn't accidentally talk to the production database and do bad things, right? So there we go. So we get from installing Jenkins X from that one simple command line, JX create cluster or JX install, we get development tools with all the things you need to do development and a staging environment and a production environment. So once you got this far, you're now ready to use Jenkins X. So now I'm going to switch to a live demo. In this case, I'm going to do a live Google Cloud. So what could possibly go wrong? I'm going to use GitHub and Google Cloud all together and hope it works. So first command, let me clear my screen a second. So the command line is JX. If I type JX, I get a whole list of commands I can use. There's lots and lots of them. Let me clear my screen because that's kind of now a bit messy. So the first command is JX get app. It tells me about all my applications, which right now I don't have any apps running in my team. And there's another command, JX get env, which shows you all of your environments. Oh, that's wrapping a bit. Let me make my terminal a bit bigger. Sorry about that. It looks a bit ugly. Let me just resize a little bit. Oh, I need to resize really big. Let me do a little bit more. There we go. That doesn't look quite so sucky. So these are all the environments we have. So we have a development environment. I have a personal environment, which I'll maybe show you at the end, a staging environment and production. And these are the Git repositories we're using to store the configurations of those environments, which I'll show you that in a few moments. So the first thing we want to do is create an application. So let's create a brand new application. So we're going to keep it real and do a new microservice. We support lots of different languages and frameworks and tools. One of the more popular frameworks these days, if you're doing microservices in cloud native development, is Spring. So we're going to create a Spring application, JX create Spring. This command JX create Spring under the covers is using the Spring initializer stuff, the start.spring.io website under the covers. So Spring is going to create a new project for us. So we get to pick which library, which language. In this case, I'm going to go Java. Groovy is obviously a good choice, but actually Kotlin is a beautiful language. I love Kotlin. But I'm going to use Java for this example. I'm going to give it a name of a demo, and I'll say vjug cool. So that's the name of the app. Now it's asking me which Spring Boot dependencies do I wish to add to this app. So I'll hit the spacebar to add that actuator, and let's add web as well, and then click space. So these are the Spring Boot dependencies we're adding. Now JX is asking, do we want to use my username for Git? Yes, I do. Do I want to initialize a Git repository? Yes, please. So now these are the files that the start.spring.io has generated for this application. So it's committed that to a Git repository now. That's cool. Now it's run something called a build pack. I'll talk a little bit about that build pack later, but it's creating a bunch of extra files to help it work on Jenkins X. Right, I'll go into a little bit more detail on that. Now it's going to push this Git repository up into, in this case, GitHub to store the Git repository. I'm going to use my personal account for this, and I'm going to use that as a repository name. So now it's created the Git code, it's creating the source code on my laptop, and it's now pushing the source code into GitHub, and it's just done that. So now I have a Git repository I can look at. Just before I look at the Git repository, I'm just going to copy and paste this command here. So there's a whole bunch of different commands you can now use to interact with Jenkins X. This little command is going to watch the activity of my project. So the -w means keep watching it. The F is a filter to filter just my project. And this little command line tool visualizes what happens on my application. So I can see the pipelines triggering away to do a release. So what we've done, let me show you the Git repository to show you that I'm not cheating. So let me click on that URL. There we go. So here's the Git repository. So this is github.com, which is just acquired by Microsoft, which I think is awesome news because Microsoft are doing amazing things these days in open source. Yes, I know there's a history with Microsoft, but they're kind of cool these days now.
James, I had exactly the same spirit, well, not thoughts about it really, because there's been a lot of negative press on Twitter about this. But,
yeah, I think that's kind of crazy, really. Like a lot of people will be saying, quick, use GitLab immediately because, I don't know, Microsoft could do bad things. I can't think of anybody better than Microsoft as a destination for GitHub. People were worried about GitHub, but, were they going to keep making money? What's their business model? Blah, 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 blah. I think Microsoft's a great destination. What Microsoft are doing with Helm is amazing, and Kubernetes and Azure is amazing. But VS Code is awesome as an IDE, right? So what I'm personally excited, I want VS Code inside GitHub.com now, right? Whenever I go to GitHub.com, I want VS Code to be able to edit any branch, any pull request. I mean, that could be amazing, right? That could be totally. Microsoft gets developers, right? They totally get developers and want to make developers happy. So I think it's got great news. I think Microsoft buying.
Yeah, GitHub, and all the people, awesome. A lot of the people they've hired actually over the last 5 or 6 years. Yes. These are the right people to lead these kind of things.
Yes, yes. We've been chatting to lots of Microsoft folks lately around developer tooling, and it's both Jenkins X is working on developer tooling and Microsoft are, and we're trying to totally align our developer tooling stories around VS Code. So we have a VS Code plugin for Jenkins X. I'll maybe show that later, awesome. Which is really, really sweet. VS Code is amazing. I love it.
Anyway, sorry, I'm making you
no worries. So Here's the source code that we've checked into Git that's automatically checked into Git. So let me just recap of what we just did. We typed one command. That one command that we typed in created a new Spring Boot application. It's created a Git repository, pushed it up to GitHub. It's run a build pack that created something like a Docker file for making the Docker image, a Jenkins file for creating the CI and CD pipeline, something called a scaffold YAML, which defines how scaffold is going to use Docker to, how it's going to create Docker images. And there's a folder called charts, which is where the Helm charts are stored. Notice everything's in Git. So if ever I want to tweak that Docker file, I just edit the file in Git. If I want to tweak the Jenkins file, I can just edit the file in Git, right? But what we're hoping is you generally won't need to even know or care that those things are there, right? They're there if you really, really need them. So we're not hiding anything, but the idea is you shouldn't really need to know or care about that stuff, right? Now, let me just pop to the pipeline thing. Notice the release has happened. So what happened under the covers is we created a Git repository. JenkinsX also then, under the covers, created a Jenkins pipeline to do CI and CD for that repository, set up the webhook so that whenever we push to the Git repository, it triggers a new release. Now this pipeline is triggered. I've been talking a bit too long. It's already done the release, and now it's promoting that release. So if I quickly go to this webpage and hit the releases page, it's created a release. It's created a new version, 001. It's created, it's tagged the source code, which is nice of it. It's created nice release notes. There's not terribly much to talk about yet because we've done the initial release. And it's also created this pull request. If I open that pull request, this is the pull request, which is promoting 001 of vjug cool into the staging environment. So this Git repository here is the Git repository for my staging environment for my cluster that I'm working with. And if I look at the diff, it's 3 lines at the moment because we've never deployed this application before. So this little bit of YAML defines which applications and which versions and which app store the app belongs in. So these 3 lines of code, you don't need to worry about these. This is just the implementation detail under the covers, but this is the code change which is being proposed in a pull request to add this application into that environment. And what's happening right now, it's probably going to finish any moment now. What's happening right now is there's a CI job as triggered to validate this pull request is valid. So there's a job that's checking, does this configuration change work? Like, is the chart okay? Is the YAML okay? Does the Docker image exist? Can I install this? And all this kind of stuff. So the pull request is generated, it's validated. Then as a team, you can then choose if you wish to merge this change, to merge this into staging. Now, what often happens in an ideal microservices way, we should automatically be going to production all the time, and we shouldn't have many manual checks for doing promotions and stuff. But in the real world, as people become more microservice-ish, we expect there's going to be, like some people might have an ops team for production, for example, who want to have the power to control when merges occur, right? So using pull requests gives us this visibility into making changes and gives us a way of approving and doing whatever CI checks we need at pull request time to validate. Do all the images? Oh, there we go. It's just been approved. The CI job worked, so it's gone green. So any moment now, it should merge and automatically merge, and then it will start promoting. So using GitOps in this way gives us a really lovely way of communicating between operations folks and developers, or communicating between a modern DevOps team or even a classic team, right? If you have a separate ops team for production, this allows developers to automate the generation of pull requests to production, and then the production folks can consider and discuss and approve those changes when they're ready to take them, rather than kind of forcing it on them. So the pull request has just merged. So the pull request, because it's merged, now a job is triggered to apply the latest version of the repository. So if I go into the Git repository, we'll see in the master branch now this requirements YAML, which is a Helm thing. Don't worry about this file, but you can see that now, because master has vjug cool inside it with version 001, a pipeline is going to run, and then that's going to apply that new change into the staging environment, and then will be reported with the URL. So just to recap what we've done, we typed one simple command to make a new Spring Boot app that immediately has triggered a release, and we're promoting it automatically to staging. Now, the important thing to remember about this, we're doing this, what we're trying to do is encourage developers to do the right thing. So rather than beavering away on your laptop and running everything locally and not thinking about CI/CD and not thinking about Kubernetes even. What we kind of want to do is flip that round. So as soon as you start, we want to release to the staging environment, and you can see we've just released to the staging environment. So we want to get people going to staging immediately and then making changes through pull requests and validating those pull requests first and doing promotions using the same approach and technique and pipeline that we're going to use to go to production. So in other words, we're trying to get people in the habit of doing the right thing all the time, rather than breathing away on your laptop for 3 months and then suddenly trying to make it work on Kubernetes. We want to start with things running on Kubernetes, and then any change that breaks your app from running on Kubernetes, we want fast feedback, right? So you can see from this, we can see here's the URL of the application running, and hopefully it should, there we go, it started. Now that URL doesn't look the most amazing screen you've ever seen in your life, but believe it or not, that is the default web page for a Spring Boot application. It shows you this stuff. If you work with Spring Boot, you will know this web page kind of quite well. So now let's change gears a little bit. Let's do a pull request. So if I go into Vdruk Cool, so here's all the source code to my application. So I'm going to create a pull request. I'm going to keep it real and do a lot of this on the command line to show there's no like weird IDE magic going on or anything. So I'm going to do create a Git branch. I'm going to do a Git branch called fixes, and I'm going to do a Git checkout of fixes. I'm going to create a GitHub issue, which we can do this via JX as well. So let's do create issue -t, and we'll give it a title: add more better homepage. Better homepage. There we go. And that's going to create an issue on GitHub. So there we go. There's the GitHub issue. Now I'm going to add some code. I'm going to make a code change. I have a little source file I made earlier to save me typing really badly in front of you all for a while. To copy that file into the source. So if I do a git status, we've got a new file. And if I do a git add source main resources, we should have added a new file. There we go. Git status. There's a new file. So we've added a new HTML file. Don't worry about the file just right now. I'll show you it later. So now I'm going to do git commit. Commit -a -m, keeping it real. Fix better homepage. Fixes, and I'll refer to the issue we've just fixed. Fixes number 1. There we go. And I'm going to do a git push. So I'm just doing normal Git stuff, right? This is not weird, wonderful magic. This is just vanilla Git stuff that most developers know Git these days, or at least can Google how to use Git. So if I go back to the homepage now, oh, would I like to create a pull request? So yes, let's make a pull request. So I click the pull request button and click create pull request. So I'm making a change. I'm proposing a change. And notice the change links to the issue that this is fixing. And if I hover over there, that's nice. It's saying add better homepage. So I've created a pull request in this Git repository, just normal vanilla Git stuff. Notice that a pipeline is triggered. So we're automating CI and CD. So I kind of demoed the CD part first. We've done a release into staging. Now I'm going to demonstrate the CI piece. And notice, for example, the pull request CI job is now running. So what that's going to do is it's going to take this pull request, check, my test pass, all my code compiles and everything, kind of all the test pass and all that kind of stuff. Another thing Jenkins X does, though, which is interesting, is we have something called preview environments. Now you can opt in and out of those, but the idea is whenever you're proposing a code change in a pull request, what Jenkins X will do by default is it will run all your tests. If it does, it will build a preview Docker image of your application, and then it will create a preview environment to run that Docker image, and then it will run the preview Helm chart of your pull request. So before we merge any change, we verify that it actually runs in Kubernetes. So you can't accidentally merge to master something that doesn't work in Kubernetes, right? So preview environments validate that your change doesn't break the application in Kubernetes, which is a kind of cool test, right? The other thing that's interesting about preview environments is, particularly if you're building web applications or front ends, if you're making a pull request and it's changing, say, some HTML markup and templates and CSS, it's sometimes a bit hard to code review that and understand what that change means to a user. With preview environments, you get to visually see what a code change is going to do before you agree to merge. So it gives you this nice way of a team discussing and reviewing a change and seeing and working and using a change before you agree to merge to master, right? And the idea is when you merge to master, we expect that's just going to immediately go out the door to staging. If you want to debate about a change, we prefer you to do that on a pull request, because then that pull request doesn't block any other change, right? So we could be debating my new homepage for a while. Meanwhile, someone could do a significant fix to some other bug fix in parallel, right? And those can go straight out. One thing I haven't mentioned yet, by the way, out of the box, every environment is set up with staging and production. You can obviously create as many environments as you wish and call them whatever you want, right? We've gone with staging and production as the two main environment names. Also, you can define whether an environment automatically promotes when a new version is available, or you can make it manual. Out of the box, we've made promotion to staging automatic, and we made production manual. So you have to type the command JX promote to production. You can obviously switch that. We'd like you to go automatic for everything, but you can, right now it's set up as automatic to staging and manual to production. So you might have just noticed here green because the tests all passed and the pipeline all kind of worked. And notice we've got a new comment here. It says a pull request built and available in a preview environment, and that's the name of the preview environment. And there's a link here to the preview application running. The URL is also in this screen here. That's the link to the application there. There's a link to the pull request, and there's a link to the application. So I'm going to actually click this link here, but they're both the same. And I'll open that. And here's my pull request running. So that HTML file I added in the pull request basically added a new homepage to the application. So now we're testing the actual application with the pull request before we've merged. So we can all kind of look at this and try it out and see what we think. And do we like this? Is it better? Yes, this is better. So then we can agree to merge. So we say, yes, this is awesome. Let's merge it. So we click the merge button. So now we've merged this pull request to the master branch. So we've agreed to do this change, and we've clicked merge. So then now you'll see that a new release pipeline is going to trigger, and that's going to make 002, and then that's going to go to staging environment. So preview environments are a really powerful way of testing out applications before at a pull request stage. You can also use preview environments to do all kinds of different things. So a preview environment just runs a Helm chart, so you can add any arbitrary other things with the preview. So you might want to run, I don't know, a load testing framework or soak testing, or you might want to do contract-based testing on the application running in Kubernetes as it would do. You might want to use all the cool stuff from service meshes and Istio and all those kind of stuff. So you might want to run your stuff in Kubernetes with Kubernetes secrets and persistent volumes and service mesh stuff, and do your test that way on a preview. Another thing we found really useful with preview environments is sometimes you're making a change, and that change is happening on the front end and the back end. So you have one pull request on the back end and one pull request on the front end. You can actually link the preview environments together so that the front end preview environment can talk to the preview environment of the back end. So you can kind of validate lots of complex microservices together in pull requests until you're ready to roll forward. So preview environments are really, really useful. We use them now all the time for almost everything we do, and they're so useful at getting fast feedback and testing stuff works before you agree to merge and then trigger, a release pipeline.
That sounds really, really useful. Actually, I can see a lot of use cases. A lot of people who would really like that. We've got a few questions that I wonder if now is
sure,
a good time
go for it. Yeah,
so
go for it.
One question from Andy Glassman asking if this will work with GitLab or other version control platforms, Bitbucket maybe, or other things.
That's a great question. Right now, today, JenkinsX supports GitHub, GitHub Enterprise, and Bitbucket Cloud. Bitbucket Server is really close. Gitea is almost there. There's just one bug we need to fix to make Gitea available. So Gitea is like an open source Git hosting solution that's written in Go and is super simple and small and lightweight. So we really like Gitea as an on-premise thing. GitLab is close, but it needs a bit of work. So GitLab, we're working on it. We basically want to support every popular Git provider. Today, GitHub is my favorite. I think GitHub is the best by a mile. So we absolutely have amazing support for GitHub and GitHub Enterprise. All the others are coming slowly. Like Bitbucket Cloud is there and works, but Bitbucket servers needs a little bit more work. And GitLab is there. We're working on it, and hopefully we'll get that working soon.
Okay, I was going to also ask about on-prem actually. So GitHub Enterprise is also supported.
That's cool. So you could, and that's either the hosted GitHub Enterprise or the on-premise GitHub Enterprise. Both are supported. So you can either have You can either have GitHub host it for you and be private, or you can have it on-premise, completely on-premise. And that totally works. But the idea is, hopefully by the end of the year, we'll have support for all significant Git providers. Yeah.
Okay, awesome. One other question from Rema S is asking where you would add your cloud subscription details.
So JenkinsX uses your credentials to install in, say, GKE or Google, Amazon, Azure. So the idea is you set up those credentials yourself and then use JenkinsX to install. So whatever your cloud provider's way of connecting to Kubernetes, we basically use that same mechanism to connect to the cloud. So if you use Google Cloud, for example, there's a connect button in Google Cloud that you just click on it and it gives you a command line to type in to authenticate and log and connect to a cloud. We use the same stuff under the covers. In JenkinsX, where everything is Kubernetes native and we're using Kubernetes resources for everything, like everything you're looking at right now are Kubernetes resources. I can do things like kubectl get environments to list the environments using kubectl, right? So because the environments are just custom. So we're using the same Kubernetes REST APIs and CLI and custom resources and everything for JenkinsX. So the security model is all the same. So we're using Kubernetes role-based authentication, Kubernetes certificates, and the way that you log into all the different clouds is all supported via Kubernetes. Does that help answer the question?
Yeah, that sounds good. We have also a question from Tool Dave. I can't verify whether that's true because we're obviously new lecture, but Tool Dave asks, is it possible to have one Jenkins instance run builds and create Docker images in a lower env cluster, but then do subsequent deploys to a separate Kubernetes cluster?
The quick answer is yes. A lot of people want multiple clusters. It's a thing a lot of people really want. Particularly for security, right? You really don't want to be building Docker images in staging or production. And it's kind of good to keep the development cluster where you're doing Docker builds and all that kind of stuff separate. So what we really would prefer is every environment, it would be kind of nice if every environment was in a separate cluster. JenkinsX totally supports that. What we don't yet have is automation to set those clusters up for you. So you have to currently manually set up the other clusters. We're working at the moment on a Terraform way of automating the configuration of multiple clusters, so that using GitOps, you can have a little Git repository to define, dev, staging, prod. And if you want them all to be separate clusters, or maybe use one cluster for staging and prod, or however you want to slice and dice your clusters and environments, define all of that in a simple piece of Terraform source code, and then run that pipeline, run that build, using some kind of CI tool to then apply your clusters. So we desperately want to automate all of that. So, but the quick answer is yes, it works. But the slightly unfortunate answer right now is we don't have automation yet in JenkinsX to set up those other clusters. So right now you basically have to manually set up the other cluster and then wire the two things together. But we're hoping to automate all of that very soon.
Awesome. And we actually have, sorry, Karam.
Go for it. Great questions, by the way. Yeah, love it.
We also have one follow-up question from Andy's question. This is from Ross Pavitt, asking about the support of other VCSs. You talking about GitHub Enterprise and GitLab and things like that. Is that also including the promotions and pull request kind of functionality? He sees that it's listed for Kubernetes hosted Git, but there's no limitations listed for GitLab.
Sorry, I just missed the beginning of that question. Was it an issue with GitLab on Kubernetes?
No, I think it's I think there are limitations listed for Kubernetes hosted Git.
Which provider, for GitLab or any provider? I'm not totally sure I get the question. We're not using. Let me guess at where this question might be coming from. We're not the use of Git with JenkinsX isn't the same as Kubernetes Git volumes. We're not using Git volumes here. This is just a Git service that we use to Git clone and do pull requests. And certainly Bitbucket and GitLab and Gitea and GitHub should all work perfectly. in Jenkins X. It's just a matter of kind of fixing the various adapters and plugins to work. There are some Git services which don't have the idea of a pull request and don't have the idea of build results in them. So some things like the Git services in, say, Amazon and Google, those might take a little bit of work to work, but we're working on it, right? And the idea is we should support any popular Git provider with time. If anyone wants to help us on any of those, if you particularly like one particular Git provider, we'd love contributions if you want to help out. But yes, they all should work. There's no limitations, as far as I'm aware, with using a Git provider that works with Kubernetes.
Perfect. That's all we have for now.
Great. So if you can remember, like half an hour ago, I created an issue. And I created a pull request, and this is the issue right now. Let me just click at the issue. One thing I haven't shown you. So while we're just chatting, we did a pull request, we showed the preview environment, we merged to master, and it did a release. There's just something else I just want to show you. Because Jenkins X knows when releases happen and when they go into staging and when they go into production, because we're doing CD, we also comment on issues to let people know when an issue hits staging or production. And then this little comment has a link to the release notes, which if I click that link, and there we go, there's the release notes. So we've generated release notes. The release notes links to the issues that are fixed and the pull request that we used to make it. So we've got nice semantic release notes. Also, we link to the actual application running in the staging environment. So if I click on that link and open that in a new tab, this is the staging. No, you might not be able to read that, but from the URL, this is the staging environment application. And this is the new application running in staging. So we've got that feedback on pull requests and issues. When we do pull requests or releases, we've got that kind of feedback loop between CI and CD, which is really super useful. Okay, so that's the main kind of demo I was going to do. Let me do one more very quick demo, because I've got to leave soon, and I want to leave a bit more time for questions. I'm going to do one more quick demo. I'm going to change gears a little bit and talk about pre-commit. Like, how do you do things before you commit code? One of the things people puzzle with is how should you do development on your laptop before you're ready to do that pull request and submit changes? And various people have tried all kinds of different things, like should use Minikube locally and all those kind of things. Jenkins X is quite opinionated, so let me show you Jenkins VS Code. So this is VS Code, a lovely IDE. I'm a huge fan. Let me make this a little bit bigger. You zoom in, a little bit chunkier. There we go, that's better. Let me make it a bit bigger. So this is VS Code. I'm using a Node.js application here just to show a bit of variety. Notice we've got a little Jenkins X plugin here, which lets us visualize all the pipelines that we're running. So here's the pipeline I was just running. And from here, we can see all the pipelines that have been running. I can kind of right click to open the application from here if I want to just check on the app and so forth. So there's integration between all of the pipelines, things like the Git repository, the pull request, and all those kind of things. Plus, if ever like a build fails, you can just right click and say, get me the build log. And it just shows to your terminal the build log, so you can kind of search it for errors and all that kind of stuff. So it helps you stay in your IDE of choice and go faster. We have a plugin that's not quite released yet for IntelliJ and Eclipse, but they're all kind of peers of each other. And they're thanks to Kubernetes resources, which you can watch and get real-time notifications of pipeline starting and stopping. What I wanted to show you was something called a dev pod. Now I've got to go fast because I'm almost out of time. So we've got something called a dev pod. Let me open this dev pod here. So Jenkins X is using build pods. Pods is a Kubernetes term for one or more containers. So we're using build pods for running CI and CD. So all the tools we need to do CI and CD, like if you're doing Java stuff, it's Maven. If you're doing Node stuff, it's NPM, and plus additional tools like Git and kubectl and Helm and JX and various other kind of binaries. So we have these build pods which have have installed all the developer tools you need to do your stuff. What we also do is have dev pods. So I've opened a dev pod. What actually this terminal is this is a terminal running in a container in the same Kubernetes cluster we're using for CI and CD. So this command, I type ls-al, this command is running in a container inside Kubernetes in my IDE. So this looks like a tool, but the lovely thing about this is really using the exact same software stack that our CI and CD pipelines are using. In this case, the exact same version of NPM, the exact same version of kubectl. So as a developer, I don't have to keep installing the right things on my laptop. I can just use the same things on the cloud. There's another thing here as well, which is interesting. As developers, we often run things like in the JVM or something on a Mac or a Windows machine, which has a completely different operating system, JVM, threading model, networking stack, and all that kind of stuff. Inside a dev pod, we're running things on the same tech stack, on the same Docker container with the same networking, IO, operating system, security, secrets, and yada, 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 right? So rather than wasting time testing the wrong thing on your laptop, you can spend time testing the thing that's actually going to run in production. So it can help be more lean and avoid waste. Now I've got a little command in here called watch. And what this watch command is going to do is it's going to do a build that went quite quickly. We've just done a Docker build in the cloud, and then we've deployed that application into my personal editing environment. If you've ever tried to install Docker on your laptop and done a Docker build, those are normally kind of slow. I have really terrible Wi-Fi at home, and a Docker build could take 20 minutes. Doing a Docker build on something like GKE is crazy fast. So the fastest place to do a Docker build is actually the cloud. So by doing your development on the cloud, it's faster. And you're just actually synchronizing source code from your laptop into the cloud, and all the big stuff like pulling and pushing Docker images, that all happens on the cloud. So what I've just done there is I've built the source code from the laptop. So what the dev pod has done, the dev pod has spun up on the cloud, and then this synchronization is happening to synchronize the source code from my laptop into that pod in the cloud. And if I type JX get app, we'll see I've got a new application now. Oh, this is wrapping terribly, I apologize. But if I click on this application, this is the app we're running. It says hello world from JenkinsX. What I'm going to do is I'm going to run a little command in the background. I've got a curl loop command, which is just going to curl that endpoint repeatedly. And now what I'm going to do is I'm going to switch back to VS Code, and I'm going to make a code change. So let's try and add a bit more awesome. So I'm going to type awesome. Now I've edited code on my laptop with a desktop IDE, right? The same thing works in all desktop IDEs. And notice that the dev pod has automatically rebuilt and deployed the application, right? That took a couple of seconds, maybe 5 seconds. And then in a couple of seconds time, this curl loop, you see the awesome demo? So we've made a live code change without committing anything to Git, and built it and deployed it on Kubernetes using the same tech stack, Helm, Kubernetes, Docker containers, and yada, yada, yada. And we've tested it live without committing. So using dev pods is our preferred way of developing on the cloud, right? I no longer run Docker on my laptop. I don't use Minikube or any of that kind of stuff. I just develop in a dev pod using the same stuff as CI and CD. So I know if my dev pod builds, I know my dev pod will work in CI and CD, and you don't get those mismatches between stuff works on your laptop but doesn't work in CI and CD, right? So that's kind of it. JenkinsX, we're trying to automate CI and CD. Let me put a couple of slides up to finish with some links. I'll distribute these afterwards, but basically we're trying to, with JenkinsX, we're trying to automate CI and CD and improve the developer experience to help you as developers get stuff done and be successful. We want everyone to become high-performing teams and to adopt continuous delivery and continuous integration and automate everything and deliver business value quickly. So please go to jenkins-x.io and try this out. If you've got any feedback at all after this this presentation, if you pop to the community link, there's a Slack channel that we all hang out in, and please just pop along and say hi and talk to us. Or if you prefer to raise issues on GitHub, or keep the questions coming on this talk, by the way. I'll take more questions if there are any. But yeah, please give it a try and let us know what you think. And we love feedback of all kinds, good and bad, and even more, we love contributions if you fancy joining the project. So there we go, thank you.
Awesome, thank you very much, James. If you've got time for a couple of questions, we do have 2 questions left. One is from Renee, asking how do we deploy different configurations or options, config maps in this setup? So, yes. For example, database configs or memory limits. Yes,
that's an awesome question. So the idea behind the GitOps piece means we have a Git repository for the staging environment. So let me quickly switch to my web browser a second. There we go. Here's the Git repository for that. So in my staging environment, I have my staging environment is basically a Helm chart where I can define in Git configuration values in this values file where I can override any value in any app that's installed in that environment. So if you've used like Spring, Spring has application.properties and application.yaml. We can basically put those property files or put parts of those property files in the environment's Git repository and manage that configuration with CI and CD. So we can manage our environment-specific configuration in the same way as we manage versioning of versions and stuff. So we can just put everything in Helm, in Git, and manage it through pull requests. And so operators can manage operational things like installing tools like Helm and Elasticsearch and whatever monitoring, management, operational tooling you wish. You can install and manage things like Istio via GitOps. So we can manage everything in the environment via GitOps, right? Whether that's environment configuration, whether that's secrets, or whether that's configuration. Secrets is slightly special case in that secrets are obviously secret. So secrets like user passwords or tokens or whatever, we ourselves use something called sealed secrets, which basically encrypts all your secrets so that you can check them into Git and you can store everything in Git and it's nice and simple. We are working at the moment on some nice Vault integration. So if you want to keep your secrets in Vault, then we'll automate the Vault bindings of your secrets, again, via GitOps and via CI and CD. Another question?
Another question from Andy Glassman. Do Jenkins, Nexus, etc., do they run locally, or is that in the Kubernetes cluster that you run?
So currently, everything's running inside the cluster. What we're doing at the moment is Jenkins X has a concept called add-ons, and it's on our roadmap. We haven't quite done it yet, but we want to make the all the registries and repositories like Nexus or Artifactory or the Docker registry you wish to use or the Helm repository you wish to use. We want to make those pluggable so that you can choose to use either Nexus or Artifactory or something else. Plus, we want to make it easy to automate linking to them. It's actually pretty straightforward to link to external Nexuses right now. Kubernetes has a thing called services, and we use a service to talk to Nexus. We can use service linking to link that service to an external Nexus or Artifactory. So that's completely supported today. The downside is you have to manually do that service linking yourself. What we're hoping to do is automate the tooling to make that step kind of more automatic. But the quick answer is yes, it's supported right now. You just have to tweak the services in your development environment, but we want to automate that through, say, Terraform or something to make it super easy to configure.
Cool. Still got time for questions, or you have to jump?
One more question, I bet.
One more
question. I think a dash. Yes.
Okay. So Ewan has got a question. Could we have DevPod on premises cluster and stage pod on the cloud?
Yes, absolutely. So each environment can be on a completely separate Kubernetes cluster. So you could have an on-premise cluster for development and a public cloud cluster for staging and production, or vice versa. You might want to develop on the public cloud because it's elastic and easy to manage and set up, and then you might have an on-premise cluster for deploying. So each environment can be on any cluster, and we absolutely support that. Yes, I think over time, I think a lot of people kind of think in their mind that there's going to be like one Kubernetes cluster. I think really clusters are going to become like cattle, not pets. I think we'll all have lots of clusters. And there's lots of things in the Kubernetes ecosystem called federation that helps merge your clusters so they kind of look like one big cluster, but really there are lots of little clusters everywhere. So I think with the way we're all going with Kubernetes is to have lots of clusters, or at least have like 3, right? One for dev, one for staging, one for production. And those could be anywhere. Right, everything you've seen today can run on premise on a Kubernetes cluster on any machines you have, or it could all run on the public cloud, or it could run on both, right? Some on public, some on private. We could also have one environment on one cloud provider and another environment on another cloud provider, right? You might have 2 production clusters, one for Amazon and one for Google or something like that. So yes, all of those things are supported, and through Terraform, they should be really easy to automate through GitOps as well, which is we're hoping to do that very, very soon. So thank you all for listening. I hope you found that useful. I'm sorry I'm running out of time. I unfortunately double booked myself. I have another webinar to do in 4 minutes time. So I apologize for that. Please pop by Slack if you have any more questions, and we can keep the conversation going, or pop by Twitter or whatever, or Slack or something. And I'm happy to answer any questions you have about any of this stuff at any point in time. So please keep the questions coming, and thank you.
And Jay Strachan is Jay Strachan is
my Twitter. Yes.
Thank you very much, James. We'll let you drop off to your next webinar. Thank you very much. Appreciate it.
Thank you very much. Cheers. Thank you.
Cheers. Bye.